Hello guys, welcome back to Math Zone African Motives. Still on our integration of partial fractions using the partial fractions to integrate certain integrals. This is one of the exams that we're going to work on of a PU 2022 exam. So we are given use partial fractions to calculate the following integrals. First part 3.1. We are asked to integrate this with respect to x. That is, let us just write our percent. The integral of x squared plus 4, everything over x minus 4 squared, like this, all right, with respect to x. So I say that when you are working with these integrals of partial fractions, one, you are supposed to work out the fraction that you are given. This is x squared plus 4 over x minus 4 squared. If we are to check this fraction properly, we'll see that this numerator has got the same exponent as the denominator, because if we expand your denominator here, the x will be raised to the exponent of a 2. And it has the same, so it's an improper fraction. On that case, you're supposed to apply your long division. But it was going to be nice if you expand it properly so that you properly see this x squared plus a 4 like this over. Remember how you expand this bracket. You're going to have a minus b squared, that concept, which gives us a squared minus 2ab. That will be 2ab plus what? Plus b squared. So that means in this case, we're going to have our a being x. So that will be x squared minus 2ab. That's 2 times a times b, which is going to be 8. So that will be 8x plus b squared, which is 4 squared, and 4 squared is what? 16. So this is what you're supposed to actually have. And as we can see, if you have expanded this, you can properly see that the numerator and the denominator has got the same exponent. This is 2, this is 2. On that condition, you're supposed to apply long division when they have got the same degree, or if the numerator has got the higher degree than what? The denominator. All right, so we are back to our long division. That will be x squared minus 8x plus 16 into this numerator, into the numerator. So this is x squared plus a 4, like this. All right, so you're going to divide always as usual. The first term is divided to the first term. So x squared divided by x squared, that is a 1. Then we multiply back everything that we see here is going to be multiplied by x squared by 1. So it's 1 times x squared, which will be x squared 1 times everything. So it's going to be minus 8x plus 16. Then we subtract everything. In this case, that's x squared minus x squared, which is a 0. So in actual sense, we were supposed to have a 0x. We're supposed to have something like plus 0x, like that. So that if we subtract this, that's a 0 minus 8, which is going to be positive 8x. For the numbers, you do the same. 4 minus 16. So 4 minus 16, that is going to be what? Minus 12, right? So this is what you're going to have if we subtract this. And if we check, if we try to divide 8x divided to this, it's impossible for us to divide. So as we can see, that means if we divide this whole part, we are going to have 1 as a whole number. So this whole part is going to give us 1 plus the remainder. So this represents our remainder, all right? So we have failed to divide. So we are going to take this as our remainder, 8x minus 12 over this function, the function that was dividing, which is x squared minus 8x plus 16. So this is what you are supposed to have at the end. And I said on that condition, it means that you are supposed to work with the remainder to be expressed into partial fractions, because if you check on our remainder here, we can be able to factorize our denominator here. We have factors of 16. These factors should give us a negative 8 if we add them. Do we have factors? That is the quotient, all right, of 16. That's a negative 4 and a negative 4. So if we multiply these two, we get a positive 16. If we add, we get a negative 8. So it's supposed to be x minus 4 into x minus 4. So these are two brackets which are the same. So you're going to write it as a squared. So this is going to be plus 8x minus 12 like this over the bracket of x minus 4 squared. So this is going to be x minus 4 squared, right? Because we've got two brackets that are the same that we are multiplying. So this is your remainder part here simplified. So we are now going to take this, express it into partial fractions. That is the whole idea of your question. So we had this, but we had to simplify and divide, right? So after doing that, you are now focusing on the remainder now to be expressed into partial fraction, which is this part of 8x minus 12 over this. So let us express this into partial fractions. So you're gonna let 8x minus 12 over x minus 4 squared. All right, so this is over x. Remember, this is a repeated linear. When it is being raised to the exponent of 2, you're going to start with a over that bracket as it over x minus 4 plus b over x minus 4 squared up to the last power that we are given, which is the exponent that of 2. If it was a 3, we're going to have plus c over x minus 4 to the exponent of 3. So you expand up to the last exponent. It's called a repeated linear factors. All right, so that is it here. Equating the numerators, we're going to have 8x from the left-hand side minus 12 is equal to a into, so this will be a into, if we divide x minus 4 into this, there are two of them. So if we divide with 1, we're going to remain with x minus 4 plus this x minus 4 squared. X minus 4 squared cancels, we get a 1. So it is going to be b times 1, which is just a b. All right, so that's it. Take advantage of the linear bracket here. There's a linear expression. So you're going to let that bracket to be equal to 0. By letting this bracket of x minus 4 to be equal to 0, it means we have eliminated this part because it is going to be multiplied by what? By a 0. So what is the value of x there? If x minus 4 is a 0, what will be x? X will be equal to what? X will be equal to a 4. So if x is equal to 4, we have to substitute on the left-hand side and find the value of b in that case, because on b, there is nothing to be substituted on b. The answer that we get on the left-hand side is your direct answer for b. Since I said in this case, we are supposed to have what? That part of a giving us a 0. The part of a is going to give us a 0 if we substitute 4, because we said x minus 4 is a 0 there. So we substitute on the left-hand side. All right, let me take my calculator to the normal mode. So that is 8. Okay, 2 like this. All right, so that's 8 times 4, which is 8 into a 4 minus a 12. So that's minus 12 like this, which is 20. So that means 20 is equal to b, because this will give us a 0, the whole of this part. So a times 0, that's a 0. So b will be what? B will be a 20. So that is how we could have calculated, in this case, the value of b. So if we check, we do not have any other linear part here on this side that we can let it to be equal to 0. So what we can simply do is to expand our brackets and equate whatever that we can in this case. All right, so here we're going to expand the brackets and equate the coefficients of equivalent terms. So on the left-hand side, we've got 8x minus 12 is equal to, on the right-hand side, what are we having? We've got a into this bracket of x minus 4. So you expand by a times x, that will be ax minus 4a. All right, expand by a plus a b. The b is not part of the bracket, just leave it like that. So at this stage, it's up to you. All right, if we since we want to calculate a, so you're going to work with either constants or we work with the coefficients of x. So it's an advantage to work with the coefficient of x because already we can see that there's only 1x and also 1x on the right-hand side. So working with the coefficients of x in this case, what does it mean? If we are working with the coefficient of x, all right, sorry for that. Let me put this one here like this. All right, so here the coefficient of x is 8. Must be equal to the coefficient of x on the right-hand side, and the coefficient of x on this side is what? Is a. So it means 8 is equal to a. Here, there's no hassle. There was no hassle of solving anything. It's just direct. All right. So these are the values that we are getting. A is equal to 8, and our b, which is equal to 20. So it means in place of a here, we are going to substitute 8. In place of b, we are going to substitute what? A 20. That's what we have expressed into partial fractions. All right. So that is it. That was the whole part of this. We are to express the remainder, this one, into partial fractions. So it means we are going to take this now as this whole part. It is going to give us 1 plus this into partial fractions. We got 2 terms, a, which is 8 over x minus 4. So this is plus 8 over x minus 4, the one that we have into partial fractions. All right, and here we've got 20 over x minus 4 squared. So this is going to be plus 20 over x minus 4 squared. So this is the whole part that we are obtaining from this function as we have expressed it in partial fractions. So what it means is that we are now supposed to integrate this. So that is how you simplify this part. After your long division, we have got this part. The remainder is the one that you work with. So from the remainder, you express it into partial fractions. Then from there, you can integrate each and every part, right? Or let me just remove this part so that I write here, guys. Let me just remove. We are done on this part here. We now know where and what was the purpose of this. So we have to express into partial fractions first. All right. So how can we integrate? Because the whole question here was not to, it's not about partial fractions. The whole question is on what? Integration. We are supposed to integrate with respect to x. So meaning to say, what is going to be our integral if we integrate everything here with respect to x? What does it mean? It means that we are simply integrating each and every term that we are given here with respect to x. So I'm going to take it this way with respect to x, each and every term, all right? So this will be equal to the integral of 1 with respect to x. So this is just 1 out of the integral. So this is just like the integral of dx. Yes, you can write 1, does not affect, all right? Plus 8 is a constant. We're going to take it out of the integral. So it's 8, the integral of 1 over x minus 4 like this with respect to x. Plus, in this case, we've got a 20. So that will be 20 out of the integral. Then we've got 1 over x minus 4 squared like this with respect to x. So this is what you're going to have at the end. And we are supposed to integrate each and every term that we are given. So the integral of 1 with respect to x, that will be x plus 8. The integral of 1 over x, remember that's a ln. We're going to have ln x minus 4. We were supposed to divide by the coefficient of x, but that one is a 1. So it was supposed to be 8 over 1 like this. So 8 over 1 does not change. It's just 8. All right. Plus 20, we're going to have the integral of this. All right. That is the integral of that part there. What are we going to have? Okay. All right. Let me do this way. We have got 2 ways. Either you're going to use substitution or you can use direct integral from our N5. We had a method or a formula that we can use to integrate such integrals like this. The integral, if we are given ax plus b to the exponent of n like this will be, the integral of this will be ax, you take the bracket as it is, as long as it's a linear bracket like this, to the exponent of n plus 1 over n plus 1, which is our exponent times the derivative of ax, which is the derivative of this ax, which gives us a. So you just take the coefficient of x, which is what? Which is a. So that's why it's only for a linear, expression. And this can be written in that format because you can have this as the integral of, you can have it in this format as the integral of x minus 4 to the exponent of minus 2 like this with respect to x. So we said we're going to integrate according to the exponent, taking the exponent. So we add a 1. So that will be x minus 4 to the exponent. If we add a 1 here, that will be minus 1 over minus 1 times the derivative of x here, which is 1. So that's it. So this is going to give us minus 1 over x minus 4, right? So we take this down, then the minus here, we can write it on top. So meaning to say this whole integral that we have was going to give us minus 1 over x minus 4 like this, plus the constant of integration. Yes, you can use substitution method. Let u be equal to x minus 4. You differentiate du dx. Then you're going to end up with 1 over u with respect to u. This will give you the ln of u. Sorry. It's going to be x squared. It's going to be 1 over u squared here. So it will be the integral of u to the exponent of minus u with respect to u. You integrate that. You end up with u to the exponent of minus 1 over minus 1, which is minus 1 over a u. But we say the u is x minus 4. So in place of this u, you substitute x minus 4, just like this part. All right, so you can also use substitution method. I want you to try to use that one and see you're going to have the same answer, just like this. All right, so that's it. We've got our final answer, just that we're going to just combine 8, the ln of x minus 4. Plus and minus, that will be a minus, so you can multiply the numerator to the numerator. That will be 20 times 1, which is 20 over x minus 4, plus the constant of integration. So these are the terms that you are supposed to have on your final answer. It's not about the order, because maybe you rearranged this in different ways. Maybe you started with this, right, and ended up with the x minus 4. It's up to you. The order is up to you, okay? But that is how you play around with a repeated linear. A repeated linear, that's where the same bracket is being raised to a certain exponent. It's either to the exponent of 2, to the exponent of 4, to the exponent of 3, whatever that you are given is called a repeated linear. You expand up to the end of what? Of that exponent that you are given. All right, that was our question 3.1. Let us check question 3.2. 3.2, again, we are given integrate with respect to x. All right, so this is question 3.2. Let us have it 3.2 here. All right, so you're going to have the integral of 7x over, this will be x plus 2 squared. So we have another repeated. If you check x plus 2, that's a repeated again. Then we've got x squared plus 3. So this x squared plus 3 represents a quadratic. This one, this one, x squared plus 3. It's an expression that cannot be factorized. It's a quadratic expression that cannot be factorized. So always you expand that in the form of ax plus b, like this, over that quadratic function, which is ax squared plus bx plus what plus c. That's how you expand a quadratic. That cannot be factorized. All right. But letting this linear, this part here, so you're going to just expand 7x over x plus 2. Like I said, this x plus 2 squared is a repeated linear. We talked about this before when we are given to the exponent of a 2, like what happened on this part of x minus 4. So meaning to say here, we are going to have two terms that we are going to take from the linear, from the repeated linear, a over the first bracket of x plus 2, then plus b over that same bracket of x plus 2, but being raised to the exponent of what? To the exponent of 2. So it is raised up to 2, so we expand up to 2, we are done. All right. Then for the quadratic, this one, we are supposed to have ax plus b, but already we used our a and our b, so we're going to have a continuation as c. So this will be c, and this will be a d. So this will be plus cx plus a d, like this, over the quadratic expression that you're given, which is the one that you're given here that cannot be factorized. That is x squared plus what? X squared plus 3. All right, that is how we are supposed to have our expression as. Then from this part, we know what to do, guys. As long this stage we have it, we can at least try to have the values of a, b, c up to d. So from the numerator here, 7x is equal to, so 7x is equal to a, the first numerator, so x plus 2. Into this, there are 2 of them, so you're going to remain with the 1 of the x plus 2 here, and the bracket of x squared plus 3. All right, plus a b, x plus 2 squared and x plus 2 squared, they will cancel. So you just remain with a bracket of x squared plus 3, like that. Then we have got a quadratic here plus this part of the quadratic, which is cx plus d, like this. this x cubed plus 3, x squared plus 3 and x squared plus 3, they will cancel. You remain with a bracket of x plus 1, x plus 2 squared as it is x plus 2 squared, like that. So this is what you're supposed to have. So from this, you have to ask yourself now, how can I calculate the value of A, B, C, up to D? That is the question. All right, let's figure out. Let's figure out. Let us start with the linear. Do we have linear terms? Linear brackets. Yes, we've got x plus 2 here and also x plus 2. So if we let the linear bracket, the bracket of x plus 2 to be equal to 0, it means x at that moment must be equal to what? Minus 2. So if x is minus 2, on the left-hand side, we're going to have 7 times minus 2, which is minus 14, is equal to. So there's no need for you to substitute minus 2 because we say this bracket is 0. So it's already 0. There's nothing. Everything is going to be the same as this part is going to be a 0. So you're going to substitute your minus 2 on B. Don't waste your time here. Don't waste your time here because there's nothing that you get from there, because that's where you took that bracket to be equal to 0. All right. So we are going to substitute minus 2. That's minus 2 squared. Minus 2 squared is what? 4. 4 plus 3, that's a 7. So this will be 7b. As you can see, you can divide by 7 by 7. So b is going to be minus 14 divided by 7, which is what? Minus 2. All right, so that's for the value of b. All right, so I'm just going to write here, we got that b is equal to what? Minus 2, because I want to use this space here. I just want to use this space here. So in the actual sense, we expanded this and we got our value of b as what? As a negative 2. All right, that is it. So if we are to check, we do not have any other linear bracket to expand. It was only the bracket of x plus 2, which was linear. All right. That was the only bracket here, the bracket of x plus 2. We no longer have a linear. This is a quadratic. We can't find value of x there. We can't find x here. This is the same bracket. We can't find x. These are two unknown values. So there we are stuck. We no longer have anything to do. You no longer have anything to equate to 0. So what do? You expand the bracket. That's where now you expand the brackets. When you are limited, when you are no longer having anything to do, any way to start from, you expand the brackets, then equate the coefficients of equivalent terms. So here we are going to expand. So on the left-hand side, we already have this in simplest form. That's 7x. So 7x is going to be, here if we check, we have got ax. So there are too many things to be considered here. We have to expand ax here into the bracket. Let me just write my b aside somewhere far, guys, because it's going to disturb me here. Remember, we said b is what? Negative 2 is that? B is negative 2. All right. Negative 2. All right. So like I was saying here, a is supposed to expand x first. A times x, you get ax. Then a times 2, you get 2a. So this will be 2a like this. But it is going to affect this bracket as it is of x squared plus what? Plus 3. So that is going to be ax times x squared, which is going to be a x to the exponent of 3, right? X squared and x, then ax and 3. This will be 3ax. So that will be 3ax. We are done. 2a times x squared. This will be 2ax squared. All right. So this will be 2ax squared. Then we've got 2a and a 3 on that part. So this 2a multiplied to 3, what are you going to have? That will be 6a. So this is going to give us a 6a. All right. We are done on the first bracket. We have to expand everything there by what? By the first bracket. But a had to multiply the first bracket, so that we'll be able to expand. We do the same thing on b. Here it's direct. B is going to multiply x squared. So this will be plus bx squared. B times 3, which is going to be 3b. Here there's nothing. All right. We do the same thing on this part. We are supposed to expand this, but take note, before that, we are supposed to have this cx plus d like this into the bracket of c of this one, x plus 2 squared, all right, into this bracket of x plus 2 squared, which is going to give us x squared plus this one, first and last is going to be 4x. That will be 4x plus 2 squared, which is a 4. So meaning to say, cx is supposed to multiply everything. Cx times this x squared, which is going to be cx cubed. All right, cx times this 4ax. So that will be 4cx squared. 4cx squared. Cx, it multiplies this 4 at the end. So it is just going to be 4cx. All right. You move on to d. You do the same thing on d. So this is d and x squared. So that will be dx squared. D multiplies 4x. So that will be 4dx. All right. Then d is going to multiply 4. So that will be 4d at the end. All right, so that's it. We have expanded every part of this. We have used this in our expansion. And this is what we have. So from equating this, what we are going to have, because we remember we just have the value of b so far. So we need the value of a, we need we need everything from this part. So this is what you're going to do on your expansion or in the expansion that you're going to have. All right, we have got x cubed on the right hand side, but here we do not have anything that has to do with x cubed. But since we have it there, it means we can equate, we can work with the coefficients of x cubed, because already there is an x cubed on the right hand side. But even though we do not have it on this side, so it means on that side it was a 0x cubed. So the coefficient of x cubed at that point, it was a 0. So this is equal to, you equate where there are x cubed on the right hand side. Here we've got x cubed, the coefficient there is a. All right, we move on. There is another x cubed here on c. This is cx cubed here. The coefficient of this x cubed is a plus c. So this is a plus c like that. We do not have any other. So even with this, there's nothing to do because we've got a and c. We do not have A, we do not have C, we just have B. So there's nothing that you're gonna do from that part. So we just have to leave it like that. All right, we just have to leave it like that. But what we know that here we can write A is equal to C or C is equal to A. That one we can just leave it like that. All right, let's move on to another part. Move on to the coefficients of x squared. Where do we have x squared? All right, on the left hand side we do not have x squared, so it means also it was a 0x squared there. So the coefficient was a 0. All right, let's move on to the right hand side. What we have on x squared? On x squared here, there's x squared. The coefficient here is what? It's 2a. We take the coefficient as it is as a positive. So this is equal to 2a. We move on. Another x squared here. The coefficient that we have is a plus b. So this will be a plus b. All right, we also have another x squared here. The coefficient that we have here is what? It's 4c. All right, we have another coefficient of x, another x squared here. The coefficient of x squared there is what? It's a d. So this will be a plus d like this. All right, so it will be like we have got a lot of things, but this is an advantage type of an equation that we have because we have the value of b. Remember that b is -2. So from equation 1, this equation that we have here, we can either make A or B or A or C the subject. We can even transpose C to the other side. So it means minus C is equal to A. All right, if you transpose C to that side, it means A is equal to what? Minus C. That is what we have here for this equation. So if A is equal to minus C, we can substitute where there is A here. We can substitute this as what? As minus C. Then B, we have the value of B here, which is what? Which is -2 like that. All right, so that means our equation is gonna be given as 0 is equal to -2c, 2 times minus c, that will be -2c. B, remember B is -2. So you're gonna have plus 4c on this part. This is just gonna remain with the c plus a d like this. So if we collect this, we're gonna take -2 this side, it becomes a 2. So 2 is equal to -2c plus 4c, that's a 2c. So this is gonna be 2c plus a d. All right, so there's nothing that we're gonna do here because this equation, it carries c and d. All right, there is c and d here. Here there is a and c. So there's nothing that we're gonna do. If we let this, it's just gonna neutralize everything. So there's nothing that we can have from this one. So we have to leave it like that again. We have to leave it like that. We move on to another one because there's nothing that we can do here. We move on to, so that is how your person will be like. So this one is another type of a person, guys. All right, so this one, that is what we had to do. So because there's nothing that we can solve, so we move on to the coefficient of x this time, from x cubed to x squared. Now we are at x. So at x, on the left-hand side, there is x there. There is 7x. So the coefficient there is a 7. So 7 is equal to, all right, let's move on to the right-hand side. We've got 3ax here. So the coefficient of this 3ax of this x is what? Is 3a. So this will be 3a. We x. Okay, we also have x here on 4 cx here. So the coefficient of x there would be what? 4c. So that's plus 4c. Just so we're gonna have it as an equation, plus 4c. We also have another x, yes, another x here on 4dx here. There is 4dx. So the coefficient of x there is what? It's 4d. All right, so I hope now we can be able to calculate any of these values, because now we've got all the letters. Remember, we said a is equal to minus c. So in place of a, I'm going to substitute minus c. So this is equal to 7 is equal to 3 times minus c. That's minus 3c plus 4c plus 4d. All right, so 7 is equal to minus 3c plus 4c. That will be what? A c. Minus 3 plus 4, that's 1c. So it's going to be a c plus a 4d like this, okay? So, okay, so this one is an advantage, because from this equation, let us just say this is equation 1. All right, let us try to make some sense here. Let us say this is our equation 1. This is our equation 2. This is our equation 3. So from equation 1, there's nothing that we're going to do. We just substitute a is equal to minus c here. So now we are left with c and d. So you can take advantage of equation 3 and equation 2. All right. We can make d the subject from equation 2. We substitute here, or you can make c the subject, whatever that you want. So from equation 2, I want to make d the subject here. Make d the subject. Make d the subject, or transpose, whatever that you want to write. So this will be 2 minus 2c is equal to what? D. So d can be written as 2 minus 2c. So in place of d here, we can substitute that. So it will be 7 is equal to c plus 4 into d in terms of c. And this is our d in terms of c, which is 2 minus 2c like this. All right. So there we can be able to solve for what? To solve for c. So 7 is equal to c. Expand the bracket. So this will be 4 times 2, which is 8. 4 times this, that will be minus 8c. All right. So that's it. Take this to the other side. It will be 7 minus 8. And 7 minus 8 is what? Minus 1 is equal to c minus 8. That's a minus 7. That's a minus 7c. So divide by 7 by minus c minus. So c is going to be 1 over 7 as a positive. All right. So we are going to have our value of c as a positive in this case. All right. So that's our c here. All right. So with this c, we can find d. We can find a. Remember we said here a is equal to minus c. So if a, right, if a is equal to minus c, let us just write it here. We're gonna write it down here. So since a is equal to minus c, therefore a is equal to minus c, which is 1 over 7. All right, so there we have got the value of what? Of a. All right, we move on to find d. D, remember we made d the subject and said d is equal to this part. So it means our d is equal to 2 minus 2 times c, which is our c. In this case, we got our c as what? 1 over 7. So this is 1 over 7. So this is going to give us the value of d. All right, so let us see on our calculator here. This is going to be 2. All right, so that's here. We're going to have 2 minus 2 into 1 over 7. This is 1 over 7 like this. All right. So this is going to give us what? 12 over 7. So this is the value of what? The value of d that we are obtaining. So we have all the values, the value of A, the value of B, the value of C, the value of D, just like the previous case that we had. So we must combine now everything into our partial, that partial fraction. Where is it? All right, so we have to combine everything here. Where did I write it? On top here, this one. So guys, because of this is gonna affect us in terms of our values. Like we've got a lot of things that we had calculated here. All right, we had got a lot of things, but this is what you're gonna do. Let us just substitute. So A is equal to minus 1/7. A here is minus 1/7. C 1/7. Guys, we know these values. Let us substitute. I'm just gonna use here because there's a lot of things on this question. All right, so I'm just gonna use this space here. I'm just going, oh, B, we need our B, which is minus 2 here, B. So remember our B. So this is going to be given as the value of A that we got, which is negative 1/7, which is negative 1/7. All right. So we remember from our C, we have our A. All right. So that one is a negative 1/7. Okay. So meaning to say here we are going to have a negative 1/7 into the bracket of x plus 2. All right, plus B. Our B, we got negative 2. So this will be negative 2 over x plus. So this is x plus 2 squared. All right. So that's it on this part. All right. Then we're going to substitute cx plus d. So we're supposed to have plus cx plus d, the value of c and x here. Remember our c was 1/7. Our c here is 1/7. And our d is 12/7. All right. So that's our c. Gonna substitute here. 1/7. So this is 1/7x plus our d, which is 12/7, everything over x squared plus a 3 like this. All right. So this is what we're supposed to have from all this part of having our partial fractions. We just wanted to have something of this nature. It's something that we can be able to integrate. It's something that we can be able to work with in our integrals. All right. So that is how we play around with this type of a question. All right. So this is it on this part. So let us simplify and see what we are going to have. This is going to be, we can take out our negative so that we can be able to integrate. There are a lot of things here. So if we are to say there's an integral with respect to x here, what are we going to do? We take out the negative 1/7. So this is negative 1. Take note, guys, our A was a negative. So this is supposed to be a negative. If this A was your B was a negative. So it's supposed to be a negative there. So it's negative 1/7, the integral of 1/x plus 2. So this is x plus 2 with respect to x like this. All right. We move on. So on this part here, we are supposed to have negative the integral again. So you're going to have negative 2, the integral of 1/x plus 2 squared. And I think we talked about this integral a lot of times. All right. Anyways, we're going to see that. Then if you were to check properly here, we were supposed to, in this case, find the integral of this. But as we can see, this is going to be difficult for us to work with. So we can split or separate this. All right, over the common denominator, which is x squared plus 3. So it means we are going to have this as plus 1/7 like this, the integral of x over the denominator of x squared plus 3 with respect to x. All right, the same, we take the 12/7, we do the same thing, plus 12/7. It means we're going to be left with the integral of 1 over, so this will be 1/x, 1/x squared plus a 3 with respect to x. We can separate our fractions. Remember, a plus b over c is the same as a over c. plus b over c. So this fraction here, we're going to separate over this denominator. So it's going to be this over the denominator, but we have to take the 1 over 7 out of the integral. And it's going to be this over the common denominator, which is what? X squared plus 3. But we have to take the 12 over 7 out of the integral like this. So that is what you were supposed to have at the end. That means we are supposed to integrate each and every part that we see here. We are supposed to have its integral. All right, with respect to x. So let us see how can we determine these integrals. Okay, the first one I think is direct. All right, the first one we're just gonna integrate. So that's why I had to write here, because you see the substitution was gonna be a lot of things. But if you write it this way, I hope all of us we can properly see. So this is it. If we remember the integral of 1 over x is going to be a ln. So this will be ln x plus 2. All right, minus, we talked about this, guys. The integral of this 1 over 2, we said we can use the formula. It end up as the integral of x plus 2 to the exponent of minus 2. We find the integral, right? If you still remember, right? We find the integral of this with the exponent. So it's going to be x plus 2 to the exponent of minus 1 over minus 1 times 1 is going to be minus 1. So this here is going to give us minus 1 over x plus 2. All right, this one we talked about it, guys. Refer to the previous question that we did. It was also familiar to this. All right. But now we've got to this part, 1 over 7. We have to integrate x over x squared plus 3. How do we integrate this? All right, there we have to think of a substitution somewhere there. All right, the integral of x over x squared plus 3 with respect to x. So there we are supposed to think of a substitution, because we can get rid of this if we let u to be equal to this. All right, so if we let our u to be equal to x squared plus 3, that means the derivative of u with respect to x is going to be 2x plus 0 here. Make dx the subject, so that will be du over 2x. So as you can see, we can get rid of this, because this will be the integral of the x, and the x will cancel if you substitute your dx. So this x and this x will cancel, you get 1 over 2. The integral of 1 over x squared plus 3, which is represented by what? By u, like this, with respect to u. So if we integrate 1 over u, so that will be a ln, so it will be ln u, which is in this case, it's ln x squared plus 3. So that will be ln of x squared plus 3. So that is how you integrate this. All right, we are supposed to apply your substitution method in that case. All right, so this here was going to give us from this whole part that we see of this integral that we had, when I have 1 over 7 into the answer, which is we got 1 over 2, the ln of x squared. So this is the ln of x squared plus 1, like this. All right, so that's it on this part. You're gonna just apply our normal substitution method. All right, then there we've got plus 12 over 7, the integral of 1 over x squared. So what are we going to have from 1 over x squared plus 3? Do we have a certain integral of this nature? Yes, we have got this integral, and I talked about this. If you check from your formula sheet on page, it must be page 3 or page 4. I'm gonna check, because I need to use that page so that to properly see. It must be on page 3, on page 4. Yes, on those integrals that we talked about on perfect squares, they can integrate perfect squares. If you check, there's a formula that we are given there as the integral of, is given like this, the integral of dx over a squared on page number 4, a squared plus b squared x squared, like this. All right, with this formula we can integrate as 1 over ab arctan bx over a plus the constant of integration. All right, what does it mean? We have got a format that is familiar here. This is 1 over x squared plus 3, which can be written in this format as the integral of 1 times dx is the same as the dx. So this, we can start with this 3. So 3 as a number to the exponent of 2. This is a constant a. So it will be the square root of 3 squared, like this. All right, plus the part of b squared is just like there's a 1. We do not have the number, so it's just 1 x squared, because we've got x squared here. So this one is just like 1 x squared. Does not affect us anything. Does not affect anything. So the answer, when guys, they are saying if you can write your expression in this format, your answer is supposed to be 1 over AB, where A is the square root of 3 and B is a 1. So this does not affect anything. Arctan of BX, where our B is 1. So this is 1 times X, which is just X over A. And remember, our A from A squared is the square root of 3. So that is what you're supposed to have from the integral. It's a formula that you have. So I want you to check that from your formula sheet again and see on page number 4. So this is going to be 1 over the square root of 3. Then we have got arctan, in this case, x over the square root of 3, like this. All right, so this is what we have, plus the constant of integration. Okay, so we have managed to integrate each and every part. As we can see, each and every part has been integrated in this case. So what are we going to do is to just simplify further whatever that we have so that we conclude our solution in this case. All right, so let us conclude here with our simplification. All right, so therefore we're going to have this. There's nothing that we're going to do here. Negative 1 over 7. The ln of x plus 2. So this is ln of x plus 2. All right, minus and the minus here on 2 minus 2. And the minus is going to be a positive. So numerator times numerator, this is same as 1. So it's negative 2 times 1, which is positive 2 over x plus 2. All right, we multiply here the same thing. 1 over 2, 1 over 7 times 1 over 2, that's 1 over 14. So this will be 1 over 14, the ln of x squared plus 1. So this is the ln of x squared plus 1, all right? That is ln squared of x. Was it x squared plus 1, this one? It is x squared plus a 3. Guys, this was a 3 here. So this is ln x squared plus a 3 here. It was a 3 from this half here, from this one. It was the one that we took from the substitution, not, it is not from this one. It the one that we took from that substitution. Guys, I just hope it was something else. All right, so that was a plus 3 there, okay? Not plus 1, that's a plus 3 there, okay? Anyways, let's simplify this. Plus here, I'm gonna multiply this, that's 12. 12 times 1, which is 12 over 7, square root of 3. You can simplify this on your calculator, or you can just leave it like that. All right, arctan x over the square root of 3. So this will be x over the square root of 3. So guys, please, I want you to correct that part that we had here of x squared plus 3. Now I can't even tell where exactly it just twisted, but that is supposed to be x squared plus 3. As you can see, I've got x squared plus 3. So now I erased that part. I could have like figured out where exactly it twisted. But here, that is what you're supposed to have as your solution at the end. This is what you're supposed to have. So guys, let us try to revise as much question papers as we can, preparing ourselves for exams ahead of time. But as you can see, N6 just also be used with your formula sheet. Try also by all means to understand your formula sheet. That way you will be able to answer any question that you are given. So these are the typical questions that you'll be given on your integrals. You just have to work with similar questions from other question papers now.